Okay, I think I got everything set up here. If folks can let me know if they can see and hear me okay. Kind of an impromptu live stream here, prompted by this fairly significant geologic event in Northern California. I wanted to provide what I could in terms of some analysis and interpretation. So if folks on the live chat can let me know if they can see and hear me okay, then we'll get started. Great. J. Scott McLean, you are always on the ball. So we'll go ahead and get right to it, friends. I'm sure others will be joining us as we go. Basically, the short of it was I was finishing up my Geology 101 lab, got back to my office, and then I'm on the USGS earthquake notification alert. And so whenever there's an earthquake above a certain threshold, I get an email automated from them. And so the email I got was for I think it was a 6.6 off the Northern California coast. So that definitely got my attention. And by the time I got in there and started looking at things, within a few minutes, it had been upgraded to a magnitude 7. So right now what we have is a magnitude 7 earthquake. You can see the big red dot here off the coast of Northern California. These smaller red dots are the aftershocks that have occurred in the area and are continuing to occur. Probably the most notable thing, we'll break this down. They've already given it an official name. Wow, that's crazy. This was not the title of the earthquake. Usually it automates to a location, you know, so many miles or kilometers from a city or a location, but they've actually given this the 2024 offshore Cape Mendocino earthquake. But the big news, along with the earthquake, which was undoubtedly felt by residents in Northern California, and because this is happening soon, the earthquake was about what do we have here, 10:45 local time. So it was about a little less than an hour ago is when this earthquake took place. Again, originally magnitude 6.6. And so undoubtedly people felt this quake. We'll look at the shake map here in a second, but it also has triggered a tsunami warning, and for Northern California coastline and maybe even southern Oregon. We'll have to see how that plays out, because as I'm going to show you here with some of the analysis, this is not the type of quake that should have produced it might not have produced a tsunami at all, or it produced probably a somewhat small tsunami. And let me just go ahead and take you to that. So if we go into this thing here, we can start to look at some of the details. And some of you might remember many moons ago, me going through earthquakes and other things and looking at these beach balls, these things called fault plane solutions. So these are incredibly valuable in times such as this one, where in the immediate aftermath of learning of an earthquake, this is the first thing I looked at when I saw this was an earthquake of sufficient magnitude 7, and it was offshore in the water. The very first thing I was thinking of was, okay, is this going to be and this fits perfectly with the Geology 101 lesson and video I just posted a few days ago on faults. Is this going to be a dip slip or up and down fault system? Because when we have up and down motion on a fault that's of this size and under the ocean, that will displace the seafloor. That displaced seafloor will then cause the ocean and the water above it to rise as a bulge and then collapse, and that actually triggers a tsunami. But what you can see here with the fault plane solution, and I know some of you love these, is this fault plane solution from this earthquake is showing us that this was purely a strike slip fault. So the fault that produced this earthquake had sideways or horizontal motion. And so I don't expect at this point it to produce much of a substantial tsunami. So that's good news for folks in Northern California and along the Pacific Northwest coast. So I don't know for sure if the tsunami warning was automated by the system based on the size and the location of the earthquake. Excuse me, or if the tsunami was actually detected. So it is possible with the instrumentation that we have in these offshore regions with pressure buoys and pressure sensors and such, that they might have actually measured a legit tsunami. But at this point, and again, I'm being cautious here, I would guess that that tsunami is not of a substantial magnitude, that it's probably pretty small and probably not a huge risk. But nonetheless, they have issued the warning, and of course that means that along the coastline there can be sirens that go off, evacuations, and the last thing I saw was the waves. If there was a tsunami, they were expecting, based on the distance when the earthquake occurred, the distance to like the San Francisco area and the speed at which the tsunami moves through the water, they were expecting that by about 12:10 local time, which would be in about, well, let's see, about 25 minutes from now. Undoubtedly, they probably have already seen, if there was a tsunami triggered, it's probably already washed up along or hit the coastline closest to this area right here. So so that's what we have so far. Let me see what else we can do here. So undoubtedly, again, this is just happening, so I'm trying to update and refresh and see the news as well. There are no reports I'm seeing so far about damage or fatalities or injuries, so that's good news. But again, it's quite early in this process. As a bit of background as to why we had an earthquake here, let's go to this fun little map here and remember what the plate boundary situation looks like off the coast of Northern California. So this is what we call a triple junction right near Cape Mendocino. That's pretty close to where this earthquake occurred. So you can see here on Google Earth, the San Andreas Fault comes up through San Francisco, then it runs offshore. But you can see this large linear feature here that goes out into the ocean, this fracture zone. This is a big transform plate boundary, and you can see that triple junction is about right here. And so we have a triple junction where three plates are colliding: the North American plate, which makes up most of California, the Pacific plate shown here in blue, and then shown in gray is the Juan de Fuca plate. And sometimes they give this lower lobe or segment of the Juan de Fuca plate. Sometimes that's called the Gorda plate. But we have three different plates converging in this area here. We have the San Andreas, which is a strike slip or sideways motion transform plate boundary strike slip system. Then as we go further north, that becomes the Cascade subduction zone. And then tying all those together is this transform system out here. So this right lateral, notice the arrows as you look across the fault are to the right. That coincides very nicely with not just the location of this quake. You can hopefully see, let me change the background so you can see it a little bit better. There we go. So you can see the USGS map actually has the plate boundaries on here, shown in red. And so you can see here, the big orange dot is the big quake, and that sits right on top of this transform plate boundary, just a bit west of the actual triple junction. And so that motion is supported by what we see with the fault plane solutions or the moment tensor solutions, or you can call those beach balls. And so that seems to jive pretty well. So that's essentially why we're seeing this earthquake occurring here today. But it's definitely a large earthquake, magnitude 7 earthquakes. We probably get maybe on an average year, maybe a dozen of those on the planet globally, worldwide. And I'd have to look and see when the last one we had in this part of California was. It's probably been quite a while. Interestingly, and I haven't dove into this a ton. Oh, I wonder why it's not showing up on this one. Let's see here. I thought there was a secondary quake right after it. Let's see. Let me see here. Let's switch that off. Maybe I was mistaken though. There was some report I saw about a quake in the Sonoma area, like within a few minutes after that. But now I'm not quite seeing that anywhere in here. So. And yeah, I'll look over at the live chat here. Thanks for joining me and your support. And I'm sure some of you might be in California. And so let's see if there's any updates here. You are just as capable as I am of providing some of this information as well. Yeah, so this is the triple junction here. Let me switch over to, I think I like the satellite view a little bit better. And so these are the aftershocks that are coming in, and we're going to see more of these. And some of these, 4.2, some of these can be definitely big enough to be felt over the area. And so we might see more of these. We should see more of these in the hours and days, weeks, and even months to come in this part of California. But a fairly substantial earthquake, but again, hopefully not one that produced a sizable tsunami. And I don't think that's the case based on my analysis, but we should probably wait till we get some sort of official word here. Yeah, so the tsunami warning was for areas of Oregon and Northern California. There was some, I mean, this one's showing a magnitude 7.3. I don't think that's accurate. The USGS has it at 7 now. The preliminary reports was a 6.6. Sometimes those earthquake magnitudes change a little bit. The automated seismograph system sends out an initial assessment, and then once they get in and look at the seismic data in a little bit more detail, they can sometimes adjust that to a more accurate reflection of the energy that the earthquake produced, which seems to be closer to magnitude 7. Trains are being held out of the Trans Bay Tube, so that's good. They've actually are clearing out trains out of the underground stations in San Francisco on the peninsula. So again, the other piece of good news here is this couldn't happen to a better part of the world in terms of preparation. California and Japan are probably two of the leaders in terms of earthquake mitigation, preparedness, systems. They have the shake alert system in California that usually alerts people. So here's the shake map here. And if we zoom in on this a little bit, this might give us a little. So remember, magnitude is one thing. Magnitude tells us a little bit about the size of the earthquake in terms of how much energy it released at the point of initiation. And this was a very shallow earthquake. This thing was only not even a kilometer deep, so very close to the surface. So most of that energy quickly was transferred laterally out through the crust and then came ashore. So people probably felt most of the energy from that earthquake as it came ashore. But this shake map here also shows us these shades of color here. You can see the kind of orange near the star where the epicenter, where the focus of the earthquake was. And then as you move towards the coastline here, the shades of orange lighten a little bit. And if I use my colorblind eyes to try to match up that shade of orange with this intensity bar down here, it looks to be somewhere in here between intensity level 6 and 7, I would say. So that's essentially how intense the shaking actually was manifested at those locations based on human observation and experience. So intensity tells us how bad the shaking was, and the shaking can vary depending on the type of home or construction style of the structure that you're in. It can depend on the subsurface geology. Are you located on top of soft saturated sediments or solid rock like granite? Those are things that will vary the intensity level. So magnitude's one thing, and this magnitude level 7 lets us know this is a very large earthquake that generated a lot of energy in the crust, in the rocks, as rocks were broken during this event. But the intensity is actually the more important thing from a human perspective. It tells us exactly, well, not exactly, but it tells us how bad the shaking is. And notice this isn't a perfect circle coming out, because even though, we don't know how bad the shaking was out here at the epicenter because no one's out there. We don't have, all we can estimate is based on the magnitude, it's probably something like that. That's why this thing has a weird shape to it. If this was actually an epicenter on land, we might see more of a symmetrical shape to it. But with so many people along the Northern California coast here and their experiences with this quake, and I'll show you where all this data comes from here in a second. So let's go to the Did You Feel It map. So far, again, this is pretty early. So here's a map showing the location of the earthquake. And then you can see down here at the bottom left corner, 205 people have already gone onto the USGS website and reported their felt experiences of the earthquake, the damage around them, how the earthquake felt, filled out a very quick survey. And that plots up with these little squares the intensity level. And you can see down here, people felt it down near the Bay Area, but with pretty weak shaking, not much damage. So that's good news. We would expect there to be more damage and more, a higher intensity level closer to the epicenter. And we're probably not seeing a lot of those just yet because, one, this is less populated than the Bay Area, and 2, these people may still be dealing with very real problems of like, is my family okay? Are things falling off of shelves? And they're not, you know, at this time, they're not getting on the computer and letting the USGS know how that was felt. So you could probably refresh this over time. Oh, look, now we're up to 11,000. So that was probably an older one there. So we have 11,000 responses, and now we can start to see those colors start to fill in. Pretty predictable pattern. The closer you get to the epicenter, the more intense the shaking was. But it looks like at most, it's very strong shaking, but damage is sort of light to moderate so far, which is good. We're not seeing this thing over here in the red category. And it would typically take a stronger earthquake, but let's remember that in 2010 in Haiti, we had a magnitude 7 earthquake. But because of the poor construction styles and the infrastructure and other factors in Haiti, and the earthquake was under the town, it was on land, we had intensity level damages closer to 9 or 10. So just because the magnitude, you know, the magnitude and the intensity don't have a perfect relationship in that manner. Sometimes a smaller earthquake can produce, more damage and more intense shaking depending on some of those factors there. Yeah, so we can probably keep updating this. I imagine this will keep going up as more of the responses come in. What people are doing there is filling out this sort of survey. So if, let's say I was, you know, somewhere in Northern California and felt this thing, I could go in here and click, you know, did you feel it? Yes. I could put in my location if I wanted to. What was my situation during the earthquake? I was inside a building. What floor were you on? Let's say the 3rd floor. How tall was the building? 3 stories. Was I asleep? You know, I was not sleeping. Did others feel it? So you can go through this whole thing, click on your responses, and then all that information from all those different people and their survey responses gets aggregated, and that's what generates the shake map here. Incredibly useful because it can help emergency response crews and search and rescue crews target areas where the shaking might be most severe. You'd think you would go closest to where the epicenter is in the urban areas, but you might have a section of town with older buildings. You might have a section of town with higher population density, or maybe different subsurface geology conditions that would produce more, risky conditions, worse shaking and worse damage from the earthquake. So anyway, so that's kind of where we're at so far. Again, this is one of those live streams where I don't have a ton planned. I'm just kind of winging it and sharing what I can with you. If you have questions, you can let me know. Looks like Amanda Jo in the live chat says the tsunami warning is canceled. But that's for Alaska, right? Okay. Yeah, so it might still be going on for California. Again, I doubt this produced a substantial tsunami. So when we look at an earthquake like this, we're worried about shaking and all the damage associated with the earthquake. But because it was an offshore environment and of sufficient magnitude, we're also concerned about the tsunami being generated. But based on the type of earthquake we saw, that's where a little bit of that geology know-how can really pay dividends for you. I doubt it's going to produce a substantial tsunami, but they've done a great job of, I think the response is appropriate. It's just, we've got a big enough earthquake. It's in the offshore region. Let's not sit there and try to look and see if it strikes slip in that. Let's just issue that tsunami warning. Let's get people off the coastlines and out of harm's way. And then over time, if we find out that that tsunami was not triggered, then we can cancel that warning. So, okay, so yeah, let's see, anything else I have here? We talked about the plate boundary. There's this other fun interactive earthquake interface here that I haven't spent. I've used this for Hawaii a little bit, but there's the earthquake there, magnitude 7, very shallow. I think it defaults to 10 kilometers a lot of times if it's very shallow. What does this allow us to do? We could animate those quakes, or I don't think the 3D view is going to be, because it's just so close to the surface. Yeah, there it is right there, just below the plane there, the horizon. So yeah, not as many earthquakes on this one just yet, but it'll be interesting in the days and weeks to come if we come back to this and and look at the time-space relationship between the main shock, this big earthquake, and then the aftershocks that come afterwards. So yeah, if you have questions, we can treat this like a normal live stream, where if you have questions and you send those through to our moderators, they can get those to me. So thanks as always to Amanda, Joe, and Susan for being very responsive, jumping quickly on the computer to help me out with this live stream. Let's see if there's any. Thanks too for folks that are donating and supporting the cause. Very helpful. But I wanted to have something put together. Thought about doing just a recorded video, but I thought this is happening in real time. Things might change, and so it might be better to get ahead of this a little bit. Let me see, anything else in the analysis that I could share with you? Yeah, like we could look at the aftershock forecast. So based on the size of this earthquake, this is kind of interesting. Right here in the middle. Within 1 week, within the next week, based on the size, the magnitude of this quake, there is a 6% chance of at least 1 magnitude 6. There's a 36% chance of at least 1 magnitude 5 or greater quake. 87% chance of magnitude 4 and greater, and then almost a certainty that there's going to be magnitude 3s and above. And we've already seen those anyway. If we get in here and kind of check out some of these aftershocks, 3.3, 3.7, 4.2. So we've, you know, breached the magnitude 4 threshold for sure with some of these aftershocks. But you can see a lot of those plot pretty close to, well, it'll be interesting also to see if they plot up, because it's close to the triple junction. So the faulting and the tectonics here get pretty complicated. This, of course, is a pretty simplified view of how things look. And the reality is there's probably lots of intersecting faults, complicated structures. You've got the Pacific plate trying to move off to the northwest. You've got the North American plate slowly moving to the southwest or west. And then you have the Juan de Fuca or Gorda plate that's moving towards the continent to the east or southeast. And so a very complicated zone here of structures. Here's another earthquake that was just added. A 5.0. So there's one big one that just took place a little bit further away. All these other aftershocks have been to the east of the main shock, and now we're getting one out here. And if we look at that one, let's see if we can get the data on this one. See if it's, yeah, too early yet, but they might have the beach ball, the moment magnet, the moment tensor solution, the fault plane solution, come in pretty soon on that one. But it's interesting to see, sometimes these strike slip fault systems, you can get some triggering of earthquakes. So you have one big earthquake that relieves the stress, but that can load up the next segment, an adjacent segment of the fault, and so it pops off with a few earthquakes. And so we'll have to see how that looks moving forward. But yeah, the aftershock forecast, we've already seen 1.5, so the 36% chance, we met that one. And we've got a couple 4s and definitely some 3s in there. But very low chance of a 6, which would definitely be felt and would be pretty substantial as well. So you can go, this is the USGS site. This is probably the one I use the most. And this is real time, so you don't necessarily need to refresh. It just adds those earthquakes as they happen. And this was the, yeah, this was the quake I was thinking of. So this occurred three minutes after this, the main 7.0 up here. There was a 4.1, not very big, that occurred right after that. And that could be, I mean, that's actually in a pretty common area of California around the Geysers geothermal power plant for earthquakes. But it does beg the question, did this bigger earthquake provide a little bit of as a triggering mechanism for these quakes right here, at least that one, because these other ones, when did these occur? Oh, these are all, yeah, same time frame. So those are all right after this big one here. So it'll be interesting to see moving forward how that analysis shakes out. But this isn't, you know, this isn't the big one per se. This isn't, you know, worst case scenarios we think about in Southern California or, you know, on the San Andreas fault. This is kind of a normal earthquake that you would expect to get in this part of Northern California near this triple junction. Not every year, of course, but, you know, maybe once every 5, 10, 15, 20 years, you build up stress, and then you get an earthquake of this magnitude. Of course, we know the San Andreas system is capable of producing up to magnitude 8 earthquakes, which is substantially larger than this one. Okay, so anything else going on in the live chat? Oh, there's lots of question marks in here. So before Amanda Jo, if Amanda Jo has some of the questions aggregated, she can send those to me. I'll take those now. Sorry, I'm a little disorganized here. I'm sort of trying to understand it, give you some valuable commentary, and then also answer your questions and help out a little bit. Oh, a lot of questions on the moment tensor thing. Yeah, let's let's dive into that a bit. So the easiest way to explain this, whenever there's an earthquake, I almost need to draw something. Okay, so you get the up and down motion on the seismogram, right? The earth is shaking, the earthquake has occurred, and that's registered at the seismograph stations as this up and down line. We call that a seismogram. And if you know anything about earthquakes, you might remember that there's different types of quakes, but the first are waves that come in, but the first set of waves that come in are called the P waves, or the primary waves. And if you look at, let me actually, I think I can find, let's see if I can find a nice little graphic here to help me with this. First motion studies earthquakes. Let's go to an image. Oh, here we go. Perfect. This will work. Awesome. This hopefully is big enough for you to see. So imagine this is actually a map, this circle here. Okay, and let's say we have 4 different stations. Okay, and notice on each one of these seismograms, hopefully you can see this well enough, that the first motion from the P wave is either a downward spike or an upward spike. And those are related to the type of movement of the ground. Remember, P waves are compressional waves, or like push-pull, like a spring or an accordion. So as that first wave comes in, are the rocks being stretched or are the rocks being squished? And so if you, for each station, each location, if you look at the first movement of the P waves and figure out if it's extension or dilation or compressional, and you plot that up on a map for all the stations, what that will reveal are zones of rocks being stretched and zones of rocks being squished. And by plotting all that data up, that allows you to figure out a couple of valuable things. One, you should see quadrants, right? So you have a quadrant of compression, rocks being squished, a quadrant over here opposite it of compression, and then 2 quadrants of extension or dilation. And that allows you, once that's plotted up, again, you have to have enough seismic stations, which there are plenty in California, that allows you to determine, and the computers do this like instantaneously, but it allows you to determine the orientation of the fault plane. In order to have this distribution of compression and extension, you either have a fault plane, in this case, that runs northwest to southeast, or there could be what's called the auxiliary plane. It could also be produced by a fault that goes northeast to southwest. And usually you can figure out what's going on there by looking at the plate boundary conditions. So we could go here and we could say, hey, we've got a triple junction here. We have kind of an east-west transform fault, and then we have these sort of northwest-southeast faults here. But that's the main faults caused by all this conflicting stress. And then you can match that up to the actual, so notice our 2 planes here, our fault planes, are either this almost east-west fault plane this way and a north-south plane running this way. So in this case, I'm assuming, and I could be wrong, but I think I'm right, that the fault, the true fault that produced this earthquake today, is this one here, a nearly east-west striking fault. And then in this case, the blue areas are the areas of compression. And so that would mean that the rocks are being compressed in that direction. So if the rocks are being stretched and then compressed, the movement of the fault is towards the compressed region. So that means this area on the north side of the fault is being compressed to the east, and on the south side of the fault, it's being compressed to the west. So if you think about that now as arrows, that would produce a right lateral strike-slip fault for that specific location. And so you can turn these things into, here's maybe a better diagram. I should have started with this one maybe. It shows a similar thing with the first movement of the P waves. Oh, all right, that one's not going to work for us. But maybe you can see it okay here. So you can see the two planes. Black is compression, the white is extension, up or down movement of the P waves. I probably lost some folks here, and that's why they're not happy with the beach balls. But the whole point is that you can look at these beach balls and you can tell what orientation the fault had and also what type of fault it was. This told me immediately it was a strike-slip fault as opposed to a reverse fault or a normal fault, which has up-down motion. Let's just put in beach balls. Earthquakes. Oh boy, I can't even spell. Yeah, so this is the pattern you would expect to see for strike-slip faults. Look like this, kind of like a I don't know, like a whatever symbol this is. Reverse faults have a big region of black or compression in the center, or on the USGS site it's blue, but same sort of thing. And then normal faults, whoops, get rid of that, have the white region in here. So kind of heady stuff, but that hopefully was somewhat helpful to some degree. Okay, a couple other questions that Amanda Jo, thanks you for sending me. From Roboto88, could Professor explain the beach balls briefly again, please? I hope I did that okay. I do plan to do like a whole video on the beach balls. But now that we have this earthquake here, we're kind of talking about it now. Yeah, moment tensor, I think I got that. Freya Coulter wants to know, could this cause an earthquake storm, quote unquote storm? Well, we're going to see more earthquakes, right? They're popping in here even as we speak. So we're going to have this main shock, the 7.0, and we're already seeing these aftershocks. So are we going to see a large clustering in space and time of earthquakes moving forward? Absolutely. I don't know if that's what I would call a storm, or we sometimes use the word swarm. Absolutely, there will be a swarm of earthquakes here if you come back in 24 hours and look at this data set here. We can also pull in all the quakes. So this goes back a week. So now I've added, so now we have different colors. So the yellow dots are going to be earthquakes that occurred in the last week. Orange ones are going to be within the last 24 hours, day, and then the red ones are within the last hour. So all those red dots there are all aftershocks that have happened in the last hour following this bigger quake here, the 7.0. Next question, a few asking, thoughts or concerns of this being a precursor? Yeah, sometimes we see, you can get sometimes, earthquakes are, it's a messy part of science for sure, but you do occasionally get, you know, a main event, in this case the magnitude 7, as a precursor to a bigger event. I don't think we're going to see that here. It's more the exception rather than the rule. I think we had stress building up across this fault. It built, it built, it built. Finally, the stress exceeded the strength of the rocks, and the rocks failed and broke, and the one side of the fault moved past the other, and that generated heat. It generated friction. It dissipated as energy. I actually read an interesting book this week that of something I didn't know. Most of the energy in an earthquake goes into friction and heating of the rocks, and a very small portion of that of that fault movement energy is manifest as earthquakes, which was pretty interesting, that, you know, most of the energy is right there on that interface, and very little is actually the earthquake itself. So yeah, I don't think this will be a precursor. Freak Glitched, to your knowledge, is any area in the West Coast potentially prone to underwater landslides? Sure, those are pretty common, but because, you know, they're in these offshore regions, so we just had this earthquake, you know, somewhere in here, and you can see the topography here on Google Earth in the subsurface. There are some fairly steep slopes here, and you can actually see some topography. You can see when sea level was lower, like this river right here actually feeds right into this offshore canyon right here. And so when sea level was was lower, we had a connection. So even though the land and the coastline is here, the continental crust, the margin of California, the true margin of California, extends out to where you see this bigger break in slope out here. That's where the continental crust ends and the ocean crust begins. Over on this side, it comes out even farther. You can see it's been displaced along this transform fault. It's dragged out this section here a bit. But yeah, you undoubtedly with this magnitude 7, there was probably very likely some offshore submarine landslides, but those are just tricky to detect. There's not a lot of instruments I'm aware of that like detects those, and because they don't produce or present much of a hazard to people, they largely go undetected, but they're very common. Karma Black, is there a possibility that this can cause an earthquake along the Juan de Fuca plate that would be damaging to the Pacific Northwest? That's a great question. The short answer is no. So there's not any precedent where we can have a, let's see, let's go back to this one here. So our earthquake was down here, and most likely our rocks were, it's probably the Pacific plate, which is sort of the big player here. Most likely the true motion was the Pacific plate trying to lurch to the west, past the Juan de Fuca or the Gorda plate. And so these earthquakes tend to occur on segments and interfaces of plate boundaries, and there's just not an easy way to have that stress then go over into the Juan de Fuca plate and cause it to shove itself underneath North America. Now there is some research being done on like earthquake triggering, like maybe this magnitude 7, the seismic waves that radiated out from that, maybe if that hits a loaded section of some other plate boundary that's, you know, on the precipice of producing an earthquake, is that other earthquake, that in this case the magnitude 7, enough of a trigger to produce the next earthquake on some adjacent segment? And it's a little messy. There's not a clear sign there, but it's less likely. So I would say, so is there a possibility? Yes. Is there a high probability? No. I would say the probability of causing another earthquake on the Juan de Fuca section here in Cascadia is very, very low. So this is really not affecting this plate boundary over here. So not a 0% chance, but very low. Packerbacker, wondering if Shawn is familiar with how to read the National Data Buoy Center data. No, I'm not. I've actually never gone on there. Station 46411 has been activated and did show activity. Okay, well that's good to know. I've never gone into that database set, so that would be interesting to look at and see. Yeah, we have offshore buoys. You know, remember that tsunami warning and mitigation, the Pacific Northwest has been pretty well outfitted, or excuse me, the Pacific Ocean has been pretty well outfitted for detecting tsunamis, and there is a tsunami alert system that's been located out of Hawaii, or although it might be somewhere else now, for quite some time. The problem with, if you remember way back to 2004, is we had this ocean pretty well wired for a tsunami, because this is the most likely place to get a tsunami. Subduction zones here in South America, Central America, the Pacific Northwest coast, subduction zones that produce tsunami here in Alaska. Of course, Hawaii's in the middle of the ocean and can get hit by tsunami from remote areas. And then all the subduction zones over here in the Western Pacific, Japan, Indonesia, down to New Zealand. But in 2004, of course, we had a tsunami here in Indonesia in the Indian Ocean, and that was a ocean basin that was not, well, it wasn't, there was no warning system. There was not a system in place to warn people about tsunamis. I think that's been since fixed and addressed. The first thing you have to do, I suppose, is you get all the countries on board to kind of like work together and put the infrastructure in place, and then have a clear, you know, communication chain to let people know of that. So I do believe that's happened since then, but that 2004 tsunami was a huge wake-up call to what we should be doing in other parts of the world. Okay, so a couple more questions here. Whoops, I don't want to open Word. Away Word. Back to the email. So Packerbacker, thank you for that. I'll try to look into that. National Data Buoy Center Station. I might write that down real quick. National Buoy Data Center and Station 46411. Yeah, so undoubtedly those buoys then can sense changes, the water at the surface, and if there was a tsunami, undoubtedly it detected it. But sometimes they cancel the tsunami when it's like, okay, it's a 4-inch or a small, it's very small, and so that could be canceled because of that. Abby wants to know, how could this have had an effect on other places? Could it start other earthquakes? Kind of talked about that with Karma's question, so that's probably been kind of taken care of there. Maybe I'll leave this up here as something for us to look at while we're waiting. Moistened Bint, what influence may this have on Cascadia? Yeah, kind of mentioned that. I say none. I say a chance, a very small, less than 1% chance, but essentially no effect on the Cascadia subduction zone or other parts to the north. Brianna Zerbriggen, could this have any effect on Mount Shasta, or is that too far away for any activity to be triggered? Yeah, Mount Shasta is in the neighborhood, and undoubtedly, I would guess the earthquake was felt in the Mount Shasta area and some of those towns around there, but probably too. We don't often get these big tectonic quakes. So here's where the earthquake occurred, about here. Here's Mount Shasta, one of the southern part of the Cascade Range. And so that's, however many, we can do this in miles or kilometers. Here's Mount Shasta. The earthquake was probably somewhere out here. So about 200 miles or 300 kilometers away. Yeah, by the time those seismic waves, and the other thing you have to remember too is when the seismic waves are moving through the rocks as they're approaching Mount Shasta, California geology is messed up and complicated. There are all sorts of different rock types in here. There's older and existing faults through here, and as those seismic waves move through all those different rocks with different properties and the faults, that it loses a lot of its energy. So by the time it gets to Mount Shasta, there's not a whole lot of energy left in those seismic waves because it's dissipated as it's moved through all these rocks here. And so I wouldn't expect there to be much of a issue with it near Mount Shasta. Yeah, Mandajo tells me she found only tsunami wave detected was off Marina Cove. It was just 10 centimeters in height. That's 5 inches or so. So very small. No other tsunami waves have been detected at any offshore buoy sites. Yeah, strikes at fault. Yeah, so good work there. And, jives with what my professional opinion was. So good to know. Lost Synapse asks if this can be a foreshock. We kind of talked about that. Probably not. Especially at the foreshock idea does happen sometimes, but again, it's more the exception rather than the rule. Typically, what happens is the stress builds up. You might get a couple small earthquakes, but very few. I mean, we could look here at what preceded this big event. So imagine, just get rid of all the orange and red earthquakes. We had one over here yesterday. There was one over here the same day. And these were 4s. So could those have been the foreshocks to this one? Possibly. It's sort of tricky to play that kind of chicken and the egg issue, though. Here's one yesterday that was a 1.9, 2.5, so on and so forth. But the foreshocks will tend to be, much smaller. And this one's a 7. And so I don't think we're going to... The chances of us seeing something bigger after this are very, very low. Remember that for big magnitude events, they're low frequency, right? We only get on average 1 magnitude 8 per year on planet Earth. Some years we don't have one, but it averages out to about an 8 or so. So the chances of us being blindsided in the next few hours or days with a 7.4, 7.6 is quite low. Giles asks, okay, Christian asks, could this one trigger the big one? This question is coming up a lot in the chat. Well, this is a big one. so it depends on how you define what the big one is. I think when we think about California and we think about the quote-unquote big one, that's usually reserved for Southern California. this section, the southern San Andreas fault system, has not had a fault of any appreciable magnitude since the 1847 Fort Tejon quake, if I remember my dates right. And so we have been waiting over 150 years for a major earthquake on the southern San Andreas fault system. But remember, fault systems are segmented, right? Even in this little view here, there's this Imperial Valley segment. There's this segment that goes near Big Bear. There's probably 5 or 6 segments of the San Andreas fault. And fault systems, as long as the San Andreas, don't all fail at once. What we had today was, it wasn't even on the San Andreas fault system. It was over here on this other, I don't know if this is the Gorda transform fault or fracture system or whatever this is called here. And B, this is a long ways away. This is several hundred miles or kilometers from this segment here. So people in Southern California did not feel it. It was probably detected, but very, very small and weak. And so, yeah, I don't think it's going to trigger. I know I've seen silly Hollywood movies where you get like one quake and then it triggers this huge quake here that goes down the system, and it just kind of unzips or something like that, and that's just not the way these things tend to behave. So, but great question, and those are the misconceptions I'm hoping to help clear up a little bit. So thanks for asking that. Giles, quake might have been in shallow water, so not a big column of water to move, which might be why there wasn't a tsunami. No, there was plenty of water there. If you if we look at where this quake occurred, let's go to this view. Let me just kind of get a good image here, and I guess I could put the latitude and longitude in on Google Earth. So I'm kind of just looking at where this is, and then if I switch over to Google Earth, probably somewhere out here, that's 7,000 feet of water. That's over a mile of water. Even if you come over here where it's shallow, that's over 3,000 feet of water. Plenty of water, and it doesn't take much water. You'd have 20 feet of water sitting on top of a earthquake of this magnitude, and if it has up and down motion, it will displace water and it will generate a tsunami. We get tsunami that occur in lakes sometimes. Lake Tahoe has had tsunami generated by earthquakes and faults there. So I don't think that the depth of the water is an issue there. This person is HVMANARVM. Care to comment on information from scientists at the University of Washington who discovered that a hole in the Juan de Fuca plate is leaking fault lubricant? Yeah, no comment, because that's something I'm not aware of, so I'm not sure. Would love to read more about that, and if you have that, you can send that through. Caitlin Rose, what is the most dangerous type of earthquake, or is it only the size that matters? That's a fun question. The most dangerous earthquake for people is the earthquake that's shallow, the earthquake that's probably fairly high in magnitude, although it doesn't have to be. And it's not even the earthquake that's dangerous. There's an old saying that earthquakes don't kill people, buildings do. So the most critical part of the equation in many instances is, what are your buildings built out of? What is the subsurface geology like? How many people live in the area? What's the population density? Those are all sort of the bigger factors that we sort of look at there. I'm still not seeing anything on damage or fatalities, which is great. That is great news. Not even anything on infrastructure. I mean, some of you might have more up-to-date information than I do. And so the tsunami warning, yeah, here's an hour ago canceled. So yeah, that's kind of what, yeah, tsunami warning canceled from the National Weather Service. They're the ones that send it out. Yeah, but I think it's a conservative approach. It's proactive. Here's a big earthquake. It's close to the coast. The tsunami could get from the epicenter to the coast in maybe 30, 40 minutes. And so until you're sure, why not? I would totally issue the tsunami warning. Better to call it off and cancel it than to not call it, actually have a tsunami, and then people are injured. So, but why was it canceled? Why was there no tsunami, or not much of one anyway? Strikes at fault. Wrong fault motion fundamentally, I think, is the main reason there. Hopefully that helped, Caitlin. M&M, could you hypothesize on the relation between the inland earthquakes at the same time? That's quite a distance away, and as a Californian, that's not something I've seen before. Yeah, I don't want to draw too many. I don't know. So I mean, it was an interesting relationship. Notice, I mean, but this is an area. If I'm in the right spot, let me go over here and make sure I'm in the right spot here. Yeah, this is a place that has a lot of quakes anyway. I don't know much about it though. It's around the Geysers geothermal area here. So if you look at it, there was already a bunch going on there anyway, well before today and this set of earthquakes. So I think it was probably mostly coincidence. I don't think, but could there have been some triggering? Maybe, but I don't think I'd draw any hard conclusions based on these two. I mean, you can see there's a clear, there's your earthquake swarm or cluster, right? Like that's quite a few earthquakes. If we go back 30 days, what does it look like? There you go. There's a whole month of earthquakes. That's 1,000 earthquakes right there in a month. 1,047 earthquakes. Some are small. A lot of them are very small, 0.3, right? Very small magnitude quakes. But there's a whole bunch of earthquakes happening. So what would be interesting to see, I guess the plot would be, is earthquakes per day in this area, and did we see a significant uptick in earthquakes today? And that would maybe be a now correlation doesn't mean causation, but that would at least be a first indicator that perhaps this larger magnitude 7 had some influence on earthquake activity down here around the geysers. So very good. Good stuff, team. Yeah, last one here on this sheet from Kim Kaufman. Could this thrust fault set off the San Andreas? So the earthquake that happened today was not on a thrust fault. It is a strike slip fault. It's a transform fault, just like the San Andreas, where it's moving side by side horizontally. And I think I answered the San Andreas part. No, very low chance, very, very low chance of you know, especially the southern San Andreas. I'd say that's as close to zero as you can get there. So, okay, one more sheet. Good stuff. I'm glad. I have no idea how many people are on here. Hopefully it's going well. Thanks as always for Susan and Amanda Joe for jumping on. This was sort of, as you could probably tell, this was a unscripted, just kind of quick thing. I thought the live stream might work well rather than just doing a recorded interview, because I had very little information at the time, and I thought if I did the live stream, then you good viewers are contributing information and questions, and it would be a little bit better. And I think I was correct that way. Okay, yeah, and thanks for all who've donated and helped out. Appreciate you. Okay, let's do this last round of questions here, and I need to get on with my day. As a quick little side note here, I will be doing a drone flight live stream tomorrow with Nature Eye and our good friend Johan. And so if you want to see the eruption going on in Iceland up close, we will be doing that. That will be at, the link's already up for that, so you should be able to find that on my YouTube channel page. But we'll be doing that at 2 p.m. Mountain Standard Time, which is 9 p.m. Iceland time, Greenwich time, whatever time zone that is. And then there'll be some big announcements coming up too, with respect to the channel. We have a big announcement regarding things you might want to wear or buy or give to your loved ones as we go into the holiday season, related to our little community here. So look for that in the next day or two. Okay, great. Next page of questions. Rapid fire. And then I think we'll wrap this up, and I'm going to go get some lunch. But yeah, good news. Good news all around, right, team? Like, big earthquake, interesting geologically. This is the kind of stuff I like, is interesting geology, things that we can all learn from, but people are safe. Like, they're not a big... So is this a natural disaster? No, not based on what we're seeing so far. Is it a natural event? Absolutely. Magnitude 7 earthquake off the coast of California? Awesome. And we're just lucky, you know, with the preparation and planning they've done in California, the tsunami warning, improvement to buildings and structures, the shake alert system. I'm sure all those things went hopefully pretty smoothly, and it's great that we have those resources available to help mitigate some of the effects from things like earthquakes. Yeah, so this will kind of be it, I think, question-wise. If there's one or two more in the chat, I'll try to scroll through and find those. I got 3 more here from Amanda Joe. Let's see, 3D modeler from Rotterdam. When the Juan de Fuca plate has disappeared and this triple section has dived down, what will happen? Yeah, that's a fun question. It's complicated. I mean, this is the essence of, if you watch the Nick Zentner stuff and you're into like plate tectonics and trying to figure out what's happened in the past, like this is the crux of it. So the question in essence is, if I get it right, is what happens when this last little plate, this little gray area here sitting off the Pacific Northwest coast, what happens when it's completely subducted or shoved underneath North America? Well, one thing that'll happen is that'll shut off the Cascade Mountain volcanoes. So this will take, of course, millions of years, maybe tens of millions of years, but you know, this plate's not going anywhere in your lifetime, but way down the road, playing the game, if you will, it probably will take tens of millions of years to completely have this plate get subducted beneath North America, which is running over the top of it. That will shut down the production of magma. So the volcanoes from Mount Shasta up into British Columbia will all start to be eroded. They will no longer be active volcanoes. And then we have and then the San Andreas Fault lengthens, and then we transform this existing plate boundary. This triple junction will actually probably start to ride up the coast. So the Mendocino triple junction here will actually migrate north as the Juan de Fuca plate gets smaller and it gets subducted. And eventually we'll have the Pacific plate shown here in blue and the North American plate shown here in yellow, and one big strike slip transform boundary. The San Andreas will connect to, what's the one up in British Columbia called? The Queen Charlotte Fault, is that what it's called? Will connect to that. So that's sort of a very quick rundown of, you know, millions of years into the future. From Zantec, where in relation to the Juan de Fuca plate and the Cascadia subduction zone was this plate? Well, right here. So here's a good map here. The earthquake today is way down here near this triple junction, just slightly west of it, along this fault system here. I don't know, I'm sure this has a name, I don't know the name of it. But along this strike slip fault system at its eastern edge right here. And so you can see that in relationship to the subduction zone, and it's at the southern end of the Juan de Fuca plate. So today's earthquake appears to be an earthquake between the Pacific plate and the Juan de Fuca or Gorda plate, and not part of the North American plate, which was nearby but not involved. And at some point, what they'll probably do, this usually happens with these earthquakes, is they will update this one and get a, yeah, here we go, the tectonic summary. This is exactly where I was going with this. So let's just read this together, shall we? We got time, 2 paragraphs. I know how to read. I can do this. Yeah, so here's the USGS's sort of rundown on this. So here's your big tectonic setting. December 5th, magnitude 7 offshore Cape Mendocino earthquake occurred approximately 100 kilometers southwest of Ferndale, California, off the coast of Northern California, in the vicinity of the Mendocino fracture zone. This earthquake occurred in the vicinity of the Mendocino triple junction, the region where the Pacific, North American, and Juan de Fuca/Gorda plates meet. Focal mechanism solutions, there's your beach balls, indicate that the rupture occurred as a result of strike slip faulting on a steeply dipping fault striking either east-southeast or north-northeast. The location, depth, and faulting mechanism indicate that this event likely occurred on or near the Mendocino fracture zone, a fault zone that strikes east-southeast and forms the boundary between the Pacific plate to the south and the subducting Gorda plate to the north. So that is this plate boundary here. This is the Mendocino fracture zone. Actually, now that they're reminding me, that's what the name of it is. I remember that now. Earthquakes are common in the region around the Mendocino triple junction. Oblique motion between the southern Juan de Fuca Gorda plate and the Pacific plates cause north-south compression within the Gorda plate and right lateral translation along the boundary between the plates. So it's complicated. It's kind of coming in at a little bit of a sideways angle. The magnitude 6.1 Ferndale earthquake, this was in 2022, occurred approximately 75 kilometers to the east on December 20th, 2022. So we have a precedent. We had a 6.4 earthquake not too far from today's 7.0 literally almost exactly 2 years ago. A magnitude 6.2 event occurred about 90 kilometers east on December 20th, 2021. Wow, interesting. We're getting December is the common denominator here. In the past century, there's been at least 40 other earthquakes of magnitude 6 or larger, including 5 magnitude 7 or larger, within 250 kilometers of today's earthquake. These prior earthquakes primarily occur on the Mendocino Transform Fault in the Cascadia subduction zone or within the Juan de Fuca Gorda Plate. So there you go, a little bit of history there, a little bit about it. I think that jives pretty well with everything I provided with you here. So the USGS and I are in agreement. Good news. That's awesome. Okay, last question from, well, maybe not the last one, but last one from Amanda Joe. Mark Rothenbuehler, has there ever been a tsunami caused by a meteor in recorded human history? Certainly meteorite strikes produce massive tsunami, like just on an incredible scale. You know, dinosaur extinction 65 million years ago. I'm not familiar with one, Mark, so a quick scan of my limited files in my brain reveals that I cannot recall a meteor strike induced tsunami in recorded human history. Could there be one that's off my radar? Absolutely, but I can't think of one at all. So alrighty. Okay, and then let me just scroll back a bit because I saw a couple questions as I was grabbing those last few. So let's see. Yeah, thank you, Andrew, and others who've donated. Very helpful. Appreciate it. Marie, could there be any effect on Mount Lassen, or are those plates areas usually unaffected by each other? Not really. Very, very low probability. Did the seismic waves pass through Mount Lassen? Yes, but with very small amplitudes and largely no effect on the volcanic system. So there's bigger things that are happening beneath the volcano that are going to be more important than this sort of regional earthquake. Time's ticking. Do we have submerged GPS bathymetry constantly monitoring around the submerged plate boundaries? I don't know. I don't know if the USGS or any other research group has. I would guess there are some, but I don't know where that data set is, if it's public access for GPS monitors under the ocean, which is essentially what you're asking. But a great question. I would be interested to know if that's something that's out there or not. So good stuff. Yeah, not bad, right? Learning on a Thursday or a Friday or wherever you are. Not too bad. So yeah, I think that's all I've got. It was fun to just kind of jump on quick, impromptu style, and just see what was going on together. I mean, I guess when I started the live stream, it was not clear to me if this was a damaging earthquake, maybe, or even a destructive earthquake. And now we can see that that's likely not the case. The tsunami warning was canceled. That would have been a huge. That would have had a huge effect if there had been a tsunami across this region, but that has dissipated and died down. So the tsunami threat is gone. And as far as I can tell, and this could change, I'm not seeing any information about any serious damage. Were things rattled off of shelves and, you know, little things like that? Possibly, but I'm not seeing anything in the news so far about any injuries or fatalities or substantial property damage. So all good news, all good news. So a fun event on a Thursday in early December, but not one that makes us feel a little sad or has any sort of tragedy tied to it. So it'll be interesting. Might do a follow-up to this. We'll have to see if there's anything of interest in the next couple days. I'll kind of watch this and look at the earthquake aftershocks, and it'll be fun to see if we get a more of an analysis from USGS or some other folks on this. That will be fun to learn and educate ourselves with. But otherwise, we'll go ahead and sign off here. Please try to join me tomorrow for the drone live stream. And I also have big news coming about our website and some products we have available to you. So if you like what we do here on my YouTube channel, our whole community of people, you can look for that. That will be happening very soon. So thanks as always to Susan and Amanda Joe for their amazing and capable work moderating the live stream. Thanks to all our awesome viewers. Good questions. I'm sure you guys answered each other's questions just as well, if not better, than what I did. But magnitude 7 is a major earthquake. So let's also remember the Earth just released an incredible amount of energy today off the coast of Northern California. Thankfully, it was not under a town, but it was, you know, some distance offshore. Thankfully, it was strike slip motion instead of dip slip or up down motion, so it did not generate a tsunami. And thankfully, California is one of the better prepared areas of our world for an earthquake to occur in. They're reminded of earthquakes so often. They've invested in earthquake mitigation and appropriate responses, just like Japan and other parts of the world as well. So good stuff. So good geology happened today. We learned some science. Definitely something that was felt and affected. Oh, I wanted to check real quick let's see where we're at with the shake map. Oh no, it's going to be the other one. This one. 13,000? Yeah, 13,000 responses so far on the shake map, and that'll undoubtedly go up as more people jump on and report how the earthquake was felt. But light damage for the most part. It'll be interesting to see where this settles. They'll kind of take an aggregate and see what it looks like the maximum intensity level on this is 8, but sometimes that can just be from a few people, and so that might slide down a little bit. 8 would be pretty substantial. I mean, that's severe shaking, moderate to heavy damage, but we're not seeing any of those reports yet. But there could be some people that right now have structural damage to their home, substantial damage in the home, maybe some injuries, but we haven't seen that yet come through the news. So we'll hope for the best. We'll hope that the preparedness of California and the responses have gone well there. So good stuff. Yeah, so I'll look for some of you tomorrow for the Iceland live stream, and a big announcement coming up about our website. And I have a couple big interviews coming up too with some folks, so look for those as well. I've got well, I don't want to announce it, I don't want to give away yet, but I've got 3 lined up in the next 2 weeks, some individuals, fellow geologists that we're going to get to know a little bit better. So just look for those in the coming weeks. But thanks for you and all your viewership and your support of the channel. Have a great day or evening or night or morning, as the case may be, and we will catch you next time. Thanks so much. Take